Section 7.4. I'm actually going to do this in 2 videos, but we're only spending 1 day on it. Starting off with defining logarithmic functions. Definition of a log. If we have a log base b of y equals x, that is only true if and only if b to the x power equals y. Okay, b is the base of the log, b is the base of the exponent, okay? X is the exponent, and then y is the argument. In this case, y is what it is equal to. Okay, so that's how logs and exponentials are related to each other. If you're taking the log of some number, you're going to ask yourself the question, b to what power equals y? Okay. Now we're going to switch in between logarithmic and exponential form. This is an essential part because when we get to solving equations, we have to switch between the forms to solve equations. Okay. So here we've got log base 3 of 81 equals 4. So if I want to switch that to exponential form, we start with the base. Okay, so the base is 3. To the power is 4, so 3 to the 4th power equals 81. Okay, 3 to the 4th power equals 81. Coming back the other way, here it's in exponential form. Let's switch it to logarithmic form. So we start by writing the log, and now the base. Well, what number is the base of the exponent? Well, there's the exponent, so there's the base. So the base is the 1/2. Okay, the 1/2 is the base. Now, the argument of the log is what it equals over here. Okay, so log base 1/2 of 32 is going to equal the exponent, which is -5. And then the last one is log base b of 1 equals 0. I left base b as b because any number to the 0 power equals 1. Okay. Evaluate. Let's say we've got to evaluate some logarithms. Okay. You don't use your calculator. I'll tell you why in a minute. Okay. Log base 4 of 64. You ask yourself this question. What power of 4 is 64? So 4 to what power equals 64? What's the power? Well, 4 squared is 16. Okay, it's not that one. How about 4 cubed? Oh, 4 cubed is 64, so the answer is 3. Here's one. Another one. Log base 1/5 of 125. So you ask yourself this question. Okay, 1/5 to what power is going to give me 125? Now, you can't forget about positives and negatives. You can even have rational exponents. So exponents come in positives and negatives and rational numbers. So think about that. 1/5, well, I know 5 to the 3rd power is 125. So maybe 1/5 to the -3rd power is 125. Okay. Next one here, log base 27 of 3. Okay, so 27 to what power is 3? Oh, okay. Let me write it down. 27 to what power is 3? Think about that for a minute. Okay. I do know that the cube root of 27 is 3. Oh, roots can be written as rational exponents. So the cube root is actually what power? The 1/3 power. talk about the calculators. I know many of you in chemistry, you have used logs with calculating pH and whatnot. You use the calculator. Okay, a common log, that's what it's called, the common log is base 10. So the button on your calculator that says log is base 10, meaning 10 to what power is going to give me this number. Okay, so, and if you ever see it on paper where they don't put a little subscript here showing you the base, then it is base 10. Hence this problem here, log of 12. What's the log of 12? Well, you use your calculator to do that. It's base 10. The other one is the natural log, which I kind of talked about when I introduced the number e, because a natural log is base e. And on your calculators, it's ln, not nl. And I think I mentioned that before. It's because it's a logarithm with a natural base. That's why they use ln. Okay. So we use the calculator to do these evaluations, and it's strictly you just press log and then 12 and press enter. Log of 12 is 1.079. Okay, and when they're giving you a log and it gives you some crazy decimal, don't round it off to the tenths. Take it out to a few decimal places. You will see in your book that they're going to use about 4 decimal places. Okay, find the log of 0.75, or the natural log, I should say. This is negative 0.2877. Okay, round it off, of course. Alright, let's get some interesting facts here. Inverse functions. G of x equals log base b of x, where b must be greater than 0 and it's not equal to 1, is the inverse of f of x equals b to the x power. So, inverse functions. These two are inverses of each other. Okay, so if we do a composite, watch, composite functions. Log base b of b to the x. Well, ask yourself that question. B to what power is b to the x? Oh, well that's pretty easy. X. Okay. And then here, of course, is the reverse, or the other one. Okay. So f of g of x equals b to the log base b of x power, and that is also going to give you x. Okay. We use this piece much more frequently than we will use this piece. For example, evaluate log base 7 of 7 to the negative 3x power. Okay. Ask yourself that question. What power of 7 is 7 to the negative 3x power? Oh, I just said it, didn't I? It's kind of redundant. The negative 3x is your answer. Log base 5 of 25 to the x. Well, this one's kind of interesting. 5 to what power is 25 to the x power? Well, I know that 25 is 5 squared, right? So let's rewrite that a little bit. Log base 5 of of 5 squared to the x power. Okay, let's rewrite that again. Because this is a power to a power, which means we multiply. Log base 5 of 5 to the 2x power equals what? Oh, wait. 5 to what power is 5 to the 2x power? 2x. Piece of cake. Okay. If this base is the same and then this number, if the base is the same as this number, your answer will always be that exponent. That number, the base is the same as this number, so my answer was that exponent. Okay, finding inverses. Okay, y equals 4 to the x. What's the inverse? Well, the inverse, this is an exponential, so the inverse is going to be a logarithmic. So the inverse is just going to be, and this is by definition, log base 4 to the x. Okay. This one, there's a little bit of work to do. Okay. With this one, we need to, of course, start with switching x and y's, because that's always the first step when finding the inverse. So it's going to be x equals the natural log of y minus 5. Now we're going to switch to exponential form, okay, because this is a natural log, and logarithms and exponentials are inverses of each other. So if I'm finding the inverse, I'm going to have to end up in exponential form eventually. Well, natural log, what's the base? Oh, e. That means e to the x power equals this number here, y minus 5. Okay, this is the argument. So e, which is the base, to this power is going to equal this number here. Add 5. So e to the x plus 5 equals y. That's my inverse.